Hey class, this video is just going to be about measuring voltage and current within circuits. We talked in the last video about what voltage is and what current is and what resistance is. And typically if we had school and we were in class, I would have you guys go create circuits and I teach you guys how to use the multimeters to measure voltage and to measure current. I'm going to do that virtually here with PHET circuits, P-H-E-T, which you guys have used once or twice before in our class. What I've got in front of you guys here is a series circuit over here on the left, and I've got a parallel circuit, which means it has a couple paths over here on the right. I'm just going to show you guys how to measure voltage and current in both of these circuits. I want you guys just to watch right now, and then when I jump over to Word, the notes I'm going to write down are what I believe you guys should be putting into your notes. And then you're going to have to know how to do this in a couple of days when I have you guys finding out properties of series and parallel circuits. So I'll start off with using a voltmeter, which is basically the same thing as our multimeters in class, and trying to figure out the voltage across certain objects. Now, we discussed before what voltage is. It's kind of like the energy of a battery or the energy of something to push electrons through a circuit. And what I can do is I can go ahead and I can just take this multimeter and I can just put one of the wires of these test leads, we'd call them, on one end of the battery and then on the other. And if you look right here, it would say 9 volts, and that's exactly what it would say in our lab in class. It would say that this battery has 9 volts. Now, this is the energy that the battery has to push electricity through the circuit. And this energy is going to be, in a sense, used up or utilized to push electrons through the certain things that has resistance. And in our circuits here, the wires have no resistance, so the thing that's pushing back against the battery is only the light bulb. So to measure how much energy from that battery is used to push electrons through it, we could put one test lead here, and we could put one test lead here, before and after. And it's also telling us 9 volts. Now, I can go ahead and switch this and it'll actually give us a positive value. But what that's basically saying is that this battery is using all of the energy from the battery. All 9 volts are used to push electrons through this light bulb that has some sort of resistance. And again, you would just touch the metal post, the metal little thing sticking out in our lab, and they would do the same thing with our multimeters in class. And same with over here. If you wanted to measure the voltage of this battery, you could measure that and it's 12 volts, or I could switch these and it would become a 12 positive 12 volt battery. And then I could go over here and touch the post before and after this light bulb, and you could do that for this light bulb as well, and you could see the amount of voltage that each light bulb is getting. So that's pretty easy and pretty straightforward. It's really easy. All you have to do is just touch before and after. You don't have to do anything to the circuit. Electricity can be flowing. The difficult one is when you're measuring current. And in real life, what you would have to do is you would have to disconnect the circuit. So let's say I want to see how much electricity is flowing in this part of the circuit. I would have to use my multimeter. I'd have to disconnect part of the circuit, and I'd have to put the multimeter in, and it tells me how many amps are in that part of the circuit. Or if, for example, I wanted to see how much current is flowing through the bottom part of this circuit, I could go ahead and I could disconnect, and I could connect my multimeter, which is represented here, and it tells me how much electricity or how much current is flowing through that part of the circuit. So that makes it very difficult to measure current because you're disconnecting parts of the circuit and then reconnecting them. And I could do that over here too. I could disconnect the wire here, and I could put my multimeter in here and test the amount of current flowing out of the battery and into those two bulbs. Or if I wanted to measure the amount of current flowing into one of the bulbs, I would have to disconnect here. And I could connect these two wires, and I could connect from there to right there, and it would tell me how much current is flowing only into this one light bulb. So in a couple days, you're going to do that with a couple circuits that look exactly like this, and you're going to figure out some rules or some properties of series and parallel circuits. So now let's take a second and jump over to Microsoft Word. So these are the things that I'm going to have you guys write down. So let's say we have a series circuit here, and it's going to one light bulb. If I said I want to measure the voltage across this light bulb, you would literally just take your multimeter. Let's pretend this was your multimeter. You don't have to draw this part. And you would take one wire there, and you take the other, the red wire, and touch there and there. So as a way, a quick, easy way of showing that, what we do a lot of times in physics is we will just say that you would go like this, and this V represents your voltmeter, your multimeter, touching before and after that object, trying to measure the amount of voltage. What we would call, this would be called a voltage drop. Um, we'll get more into that later, but this voltage drop is how much of the energy is used um, by this light bulb, or how much energy, sorry, I should say, how much energy is used from the battery to push electrons through this part. And maybe if we had another light bulb in this here, we could touch before and after. Let me redraw that for a second. We could touch before and after, and this would be the voltage drop across this. Again, how much energy, how much voltage from the battery is used to push electrons through these. And they very well could have different voltages depending on the type of light bulb the in the circuit. Now let's say I have a parallel circuit. And I want to measure how much current is going through the circuit. What I would have to do is disconnect the circuit. So what we can do here is we could do something like this. We could draw this, and we could draw this and say that we are going to place the ammeter right there. And that is going to measure the current that is coming out of the battery and flowing through that circuit. Or let's say someone asked you to measure the amount of current possibly flowing out of this light bulb. We'll call it light bulb B and that light bulb A. We could follow this electricity as it flows, out through the battery, splits, goes through light bulb A, or possibly splits and goes through light bulb B. And then we could also put our little ammeter, our little multimeter right there. And what this is doing is this is measuring the current in bulb B. So what you guys need to know is that voltages measured in parallel, meaning that we can just make another circuit, another path for electricity to flow through here and back out, whereas in measuring current is measured in series, meaning that we are literally forcing the electricity to go through the wires, through our multimeter, and through the rest of our circuit. So like right here, or it has to go through our bulb and through the multimeter, which we're labeling an A for amps, and V is obviously for volts. I think that's about it. You just need to know how to measure that stuff, and it's also good to know, like, a lot of times when I uh, want you to measure things, I might put, an ammeter here, or I might say measure your voltage here, and I'll draw it just the way we did here with volts and amps placed directly into the circuit. So we're going to use this in our next lab in a couple days. If you have any questions, let me know. Thank you.